Every time we type a question into an AI chatbot, it feels like actual magic, right? You get these instant answers from what feels like a disembodied digital mind. But behind that screen, there's a massive physical world of servers, power, and water. Today, we're going to pull back the curtain and uncover the invisible, resource-heavy footprint of artificial intelligence. And it all starts with just one question.
Okay, so to really get our heads around this, we're going to start small, like really small. We're going to focus on a single interaction, one single prompt that you might type into an AI, and look at its tangible, physical cost.
So think about it. When you ask ChatGPT to write an email for you or maybe help you solve a math problem, what do you think is the real-world cost for that answer? And I'm not just talking about electricity.
Get this, the answer is about 500 milliliters of fresh water. Yeah, that's a standard water bottle. An AI like ChatGPT basically drinks one of these for every 10 to 50 questions you ask it. Now just try to imagine hundreds of millions of people all asking questions every single day. That's a lot of water bottles.
Okay, so we've seen the cost of a few prompts, a single bottle of water. Now let's zoom out. Because when you look at the entire industry, that one bottle multiplies into an almost unimaginable thirst. And this is where the numbers start to get truly mind-boggling.
So, check this out. In its 2022 report, Microsoft revealed its global water usage shot up by 34% to nearly 1.7 billion gallons. But here's the really wild part. This was before their AI chatbot, Copilot, was even widely launched.
And if you think that's a lot, Google's numbers are even bigger. In 2022, their data centers and offices drank up 5.6 billion gallons of water. That's a 21% jump from the year before. And again, this is mostly before the generative AI boom really took off. This is just setting the stage.
So what does billions of gallons even look like? It's hard to picture, right? Well, for Microsoft, it's enough water to fill over 2,500 Olympic-sized swimming pools. For Google, it's almost 8,500. We are talking about an immense volume of water year after year. And then demand is just accelerating. Researchers are projecting that by 2027, the global thirst for AI could be responsible for up to 6.6 billion cubic meters of water withdrawal every year. To put that in perspective, that's roughly the total amount of water the entire state of Washington withdraws in a year.
So why is AI so incredibly thirsty? The answer isn't in the software or the algorithms. It's in the immense amount of heat that gets generated by what we call the cloud.
It's so easy to think of the cloud as this intangible thing floating around up there. But it's not. The cloud is very much on the ground. It has a physical address. It lives inside thousands of massive warehouses packed to the gills with powerful computer servers. These data centers are the physical backbone of our digital world, and they consume an enormous amount of energy.
And all that energy has to go somewhere. It becomes heat, a ton of heat. Those servers have to be kept cool 24/7, or they'll literally melt down. One of the most common ways to do that is with liquid cooling. Basically, a coolant pulls heat away from the computer chips, and then massive amounts of fresh water are used to cool down that coolant. The now hot water gets pumped to these giant cooling towers, where a huge portion of it, sometimes up to 80%, just evaporates into the atmosphere. It's gone.
Now here's the real challenge. Generative AI is uniquely power-hungry. A single query to ChatGPT needs almost 10 times more electricity than a classic Google search. And what does more electricity mean? It means more heat. And more heat means a much, much greater need for cooling. And that means more water. This intense demand for power and water isn't just some abstract problem for tech companies to figure out. It's creating very real conflicts right here on the ground as local communities start to push back to protect their own essential resources.
This quote just nails it. We talk about algorithms and processing power and all this complex tech, but the true ceiling for AI's future, the real bottleneck, might be something way more basic: fresh water.
And we're already seeing this friction play out. Protests have been popping up in countries all over the world. In Uruguay, which just suffered its worst drought in 74 years, citizens protested a planned Google data center. It's the same story in parts of Chile, Spain, India, even the United States, as local communities worry that big tech is literally drinking their water supply dry.
And it's not just water, it's our power grids too.
The massive energy draw from these data centers is straining our aging infrastructure to its breaking point. In places like Virginia's Data Center Alley, utilities have actually had to pause new connections. Some are even delaying the shutdown of coal-fired power plants just to meet the demand. Think about that. We're potentially going backward on green energy.
Okay, so the industry knows this is a huge problem. You better believe they do. And a frantic race is on to find innovative ways to power and cool this AI revolution without, draining the planet.
And the solutions they're looking at are pretty incredible, ranging from the practical, like more efficient direct-to-chip cooling, to the truly radical. Companies are testing everything from building data centers underwater or in the Arctic to powering them with on-site mini-nuclear reactors, all the way to futuristic ideas like processing data on satellites way up in space.
But beyond all the sci-fi solutions, the real holy grail here is efficiency. The goal is what they call getting more work per watt. It's all about designing smarter hardware and software, things that can deliver these incredible AI results while using fundamentally less energy. Because less energy means less heat, and less heat means less water.
And that brings us to the final and really the most critical question. The computing power that AI is going to need is expected to grow by more than 1 million times in just the next 5 years. 1 million times. So the solutions we're seeing are promising for sure, but the demand is just growing exponentially. The defining challenge of our time might be this exact race. Can our innovation in efficiency and sustainability actually outpace AI's insatiable appetite?